Hello, Mr. Eric, Mr. Ryan, are you right?
Yeah.
Okay, so today we're going to study a very interesting problem, combination. Okay, so I think we talk about it many times. So let's say you are here, right? You are on the bottom left, and there's a grid. Okay, grid of the, let's say,
4x4.
Okay. Okay, that's it.
That's-
Right? Your destination is here.
That looks so uneven.
That's fine. Your destination is here. For example, like Tesco here. Okay.
What?
Okay. And then you are here. You are at this point. So you can only go right, which is the east, and you can only go the one step up, which is north.
Oh, I know that.
So
I know
yeah,
that.
you can only move east and move north. And then the question is that how many ways can you get to this point? Suppose you are here and then you want to go to Tesco on the top right corner, and then one step you can move one step to the right and one step to the north. Then you can't go left and down. Okay, so the question is that how many ways
Is it
from
96?
here to here?
Is it 96? I'm not sure.
96. How do you get 96?
I don't know. I just guessed.
Eric, have you any thoughts?
I'm just thinking that out of a trip, in total, you'll go 4 up and 3 to right. And then
Yeah, 4 up, and 3 right? Well done. That's a very good observation, right? 4 up, 1, 2, 3, 4, and 3 right, 1, 2, 3. Yes, well done. And then what's
just
next?
have to calculate the possibilities, like how many ways to like sort them around, you know.
Okay, so 4 ups and 3 rights. How many steps in total?
7.
Okay, so 7 steps, and then you need to pick 4 steps up. We talk about that, right? 7 steps, right? So 4 plus 3 steps. You can pick 4 steps up, right? When you pick 4 steps up, it's the same as picking 3 to the right? Yeah? So we talk about it, right? CNM equals CNN minus M. There are n things, n apples. You want to pick m apples. It's the same thing as n apples, pick n minus apples, right? One simple example. Here, right? This is a simple example. There are 7 steps. We want to pick 4 steps to go up. It's the same thing as we pick 3 steps to go right? Does it make sense? So what's the answer? And in computer, we can do this, right? Here, it's 0, right? So how many ways we get to this point? If I want to put here, how many ways?
1,
1, yeah. Here?
2,
How is it 2? How can you? 1, yeah?
and 1.
1. Here?
1.
Yeah.
And then it's like 2.
2. How do you get this 2? Yeah.
1 up, 1 right, or
Yes.
1 right.
Because
1
to get
up.
to this point, you can only come from this point and this point, right? So this is 2. And same here.
2.
Well, how is it 2? At this point, what number should I put here?
No,
3, yeah? 2 plus 1,
is it
3.
like Pascal's triangle?
Well done. I haven't finished yet. And then this will be 4. Huh?
It's
Okay, let's just fill in this number, okay?
12.
3,
1, this is 1, 2, this is 3.
4,
So this is 1, this 3 is 4.
5,
So this 3,
6.
6. Okay, so this is 5, right?
Yeah.
This is 10.
Yeah.
This is 10. This is 10. Right?
No,
Is it?
4 plus 6, yeah, 5 plus 7, 15.
15. And then this is 25. Is that true?
No, why is the ones on the right 10, right? Is it like 6 plus 4 and then 10 plus 10 does not equal 10, right?
Which number I feel it wrong?
10 plus 10 equals 10, that part. The part with 3.
This is 20, yeah?
But I think 5. But
25.
Mhm.
Is that right?
Yeah.
Okay, so look at this. 1, 1.
Really?
Look, this is 1, right? And
Does Pascal's triangle go like that? I'm not sure if it goes like that. 3, 6, 4, 7.
okay, so at the beginning you only have 1 way. So 1, 1, 1, 1, 2, 1, right? 1, 3, 3, 1, 1, 4, 6, 4, 1, right? And then this is 1, 5, 10, 10, 5. Okay, so if you rotate this 90 degrees, this is a Pascal triangle, right? Why? Why this is this a coincidence?
Yes.
Coincidence?
No,
Obviously no. Otherwise.
So how can you explain the? How can you explain this one? I rotate at 90 degree is the same as the Pascal triangle. Remember what do we?
Just adding.
Yes. Look.
You're just adding.
Yeah, you're just adding. You just go. Like I can just have that whiteboard and like put ones on the side. Yeah, no. It's Pascal.
Yeah. Look at this one. Yeah, Pascal triangle. The sum. The number equals the sum of its shoulders. So it's basically the sum of two directions. If you rotate it, so it's the same, right? Yeah. Okay. So how do we know? How can we calculate C and M? Right? So what's this number? C, let's say C 120. You know, this should be a very big number, but we want to know how do we calculate that. Okay. Let's take a small example, okay? Because this number could be too big. Let's say, sorry?
Can you teach us a formula? I forgot.
Formula. Yes, I'm going to
Is
teach
it like
you.
something divided by 2?
Yeah, okay, that's very good. Okay, let's say three triangles, 2 square. Okay. How many ways? Let's say how many ways I want to pick. You know, I want to
10.
I haven't finished yet. So 3 triangles, 2 squares. How many ways to pick triangles and how equals to how many ways to pick square, right? Yes? Okay, so let's label it. There's 1, 2, 3. And then this is 4, 5, okay? So let's forget about the shape. How many ways to do a full permutation of these? 1, 2, 3, 4, 5. How many ways? You can get that, right? You get it. How many ways? There are 5. There are 5 slots, okay? You know, I want to permutate, full permutation of that. There are 5. So first choice, how many choice? Forget about the shape. There are 5, right? What's the second? How many choice? 4, right? This is a full permutation. Do you understand? How many? Look, 1, 2, 3. How many ways to permutate it? How many possibilities? 6. How do we get it? The first one is 3 choice. The second one is 2 choice. The third one is 1 choice, right? Yes? The same, 5. Forget about shape. How many ways? 5 times 4 times 3 times 2 times 1, right? This is 5 factorial, right? Yes? But look, this contains duplicates. Why? For example, like 1, 2, 3, 4, 5. This is the one permutation, right? It's the same as 1, 3, 2, 4, 5, right? Because look, these two are both triangles, so there could be duplicates. Yes?
Yeah.
So let's say, how many duplicates? Look, if this one, we choose this one permutation. How many duplicates? How many duplicates? How many duplicates? For 6, yes. No, that's 3 square, right? Because there are 3 triangles. How many duplicates for this? 2, right? 2, yeah? So for each type, we have permutation left. So it's equals to, so let's say C 5, 3. This is equals to 5 factorial because that's total number of permutation. But we need to divide it by 3 factorial times 2 factorial. These two, picking squares and picking triangles are independent. So the multiplication rule, right? Do you understand multiplication rules?
Yeah.
Yeah, multiplication rule, right? So the number of ways to pick triangles and number of ways of picking squares are different, are independent. So it must have these duplicates. So if I divide that's the number. So look, what's this? Cn plus, look, let's try this way, okay? Cn plus mn equals n plus n factorial divided by n factorial, right? Apples, triangles, squares divided by triangle squares. Okay, got it? Yes? Does it make sense? Mm-hmm. You understand now, right? Remember this example, okay? Mm-hmm. Okay. Cn2, we know that, right? This is a simple. You need to remember this Cn2. This is a very simple. I mean, it could appear a lot in your exam paper. C52 equals
10.
11.
equals what? So look, because this, right? We can also write it this way.
Just leave.
Cnm equals n factorial divided by n factorial and then n minus n factorial, right? This is the same thing because I put it n plus n. Okay? It's the same thing, but I think this one could be easy to understand.
clear.
Okay, so y, look, 5 factorial, C52 is 5 factorial, yeah, divided by 2 factorial, divided by 5 minus 2 factorial, 3 factorial. Okay? Yeah, so 5 times 4 times 3 times 2 times 1. 2 times 1 times 3 times 2 times 1. Okay, cancel out. Okay, so Cn2, actually Cn2 is equals to n times n minus 1 divided by 2. Okay, 5 apples, picking 2 apples equals 5 times 4 divided by 2. Okay, get this. Okay,
Yeah.
actually, permutation, right? Cnn equals what? Let's say it's equals to Pnm divided by m factorial. What's Pnm? With the, look, 3 apple picking 2 apple, how many ways? 3 apple picking 2 apples, 3 ways, right? Like 1, 2, 1, 3,
2, 3.
2, 3. Okay, yeah. This is C3, 2.
And
Okay.
isn't P the 6?
Yeah.
Because
What's
you
P?
do-
P is that each one you can have
Reverse.
different, right? You can have 1, 2, and 2, 1. 1, 3, and 3, 1. 2, 3, and 3, 2, right? Okay. So P3, 2. So P3, 2. Can we think of this way? So C3, 2 equals with P3, 2
Divided by 2.
divided by how many ways to permutate, right? Does it make sense? Yeah? Okay. So that's how we get this formula. Coming back to the question, okay? Coming back to this, you are here. You want to go to the top right. Let's say here, right?
No,
Let's say
no,
if-
it's 3 by 3.
Okay, that's fine. You want to go from left bottom to top right, but you can't reach this bottom half because it's too dangerous. There are
What?
dinosaurs there, okay?
No,
There are dinosaurs there. How many
no
ways?
way.
What do you mean no way? You know,
On the way to Tesco.
okay, Pascal. Yeah, there are dinosaurs here, so you can't reach this point. How many points? How many ways? How many ways?
Infinite ways.
No, we can still do the same, right? We can still use.
No. You could do the same, but you could also go in a helicopter and go over the dinosaurs.
Exactly.
Okay, but we talk about it. We want to count how many ways. We can still use that, right? Remember, previously we do this counting, right? We do this counting, and then we can use the computer to solve this, which use dynamic programming, right? Because the if we want to reach this point, we know it's coming from here or here, right? And then, do we care how many ways? Do we care how we get to this point? Do we care how to get there? We don't, right? We just need to We just need to count how many ways to get there, but we don't care how do we get there, right? That's the thing. That's the concept of dynamic programming. We use the previous results, okay? So we can do the same thing, right? This is 1. Here on the bottom half should be all 0, right? You can touch the diagonals, but you're not crossing the going to the bottom half, right? This should be all 0. So we can just do this counting, right? 1, this is 1. 1, you can touch here, right? 1, right? 1, 1. And then here, 1, 1, this will be 2. 1, 2, this will be 3. This is 2. And then you can go to here, right? 2, right? 2, 3, 5, right? Yeah? And then here will be 0. So there are 5 ways. Yeah? This is dynamic programming, okay? Yeah? But
So the one before had like 35 ways. Like.
oh yeah, previous 35 ways, but we are allowed to touch these diagonal, but we are not allowed to go to the bottom half, right? And then we can use computer to solve this. We just fill the bottom half as the zeros, and then we accumulate the answers there. Actually, next lesson I'm going to talk about this because there's a very interesting way to.
Alright, bye.
No, yeah. Interesting way to count that. It's called Catalan number. Catalan numbers.
Krakow is Catalina.
Okay, let's move it to next lesson because there's one actual mathematics number which is called Catalan number, which describe how we solve this problem, and it's a little bit complicated. Okay, what's the sum of each one?
10.
It's like powers of 2.
Powers 2. Why?
Because powers of 2 is powers of 2.
Powers 2. It's how?
Isn't
Why?
it-
Yeah, it's power 2. Yes,
Does it
this
have
is 2
something
to the
do
power
with
0.
binary? Does this have something to do with binary or something?
Yeah, it's power of 2. But
Does it have
okay,
something to do with binary or something?
no. It's actually okay. Let's try this way. 1 plus. Okay, Actually, I shouldn't remove that. This is going to be very interesting. Okay, here, look at this. Okay, so this one, 1 plus x 0. Okay, and anything apart from if x is not minus 1, if this is not 0, this should evaluate to 1, right? Because any number which is not a base 0 to the power of 0 is 1. Okay, this one, 1 plus x 1 equals 1 plus x. This one, 1 plus x square equals 1 plus 2x plus s square. 1, 2, 1, 1, 1. Here, 1 plus x cubic equals 1. Okay, let's say x square, s cubic. So what number should I put? What number should I put here? 1, 3, 3, 1.
Yeah, but why'd you do that 1 plus x cubic or whatever? Why'd you do that in the first place?
Good point. If I replace x with 1, what happened? If I replace x as 1,
I know, but what does that, like, thing in, like, the brackets, you know? Like, what does that have to do with a Pascal triangle?
but do you see this?
I
Why?
know.
I know.
But I don't see it, like...
You don't see how they correlate, right?
What? I guess, but I don't know what that means. Yeah.
Okay, so I'm just saying that look, 1 to 1, look, 1 plus x squared. If you if unfold it, it will become that, right? We know that, right? Yeah.
Yeah.
A plus b squared equals a squared plus b squared plus 2ab, right? Okay. If a is 1, then this is 1. This is exactly here, right? Okay. So why? Look, two things. You can think about this as triangle. This is square. Okay? So what's this mean? It means 1 plus x times 1 plus x times 1 plus x 3 times, right? Let's replace 1 as triangle. This is square. Triangle. Square. Triangle. Square. So each bracket we can make a choice. We pick triangle or square. Pick triangle or square. Pick triangle or square. Right? Remember this thing. Turning right, we can think of it as triangle. Turning up, square. Right? You said 7 step. 7 step. I want to pick 3 step going right. 4 step going up. It's the same thing as 7 shape. I want to pick 3 shape as triangle. 4 shape as square. Same thing. It's mapping, 1-to-1 mapping. Okay. So here, right, for each one, we can pick either square or triangle, right? Yes? And then this line. What's so special about this diagonal, reverse diagonal? Each point here, x plus y is n, right? Is n. Does it make sense? Look, 3 step up, 1 step not. Yeah? Let's do it this way. Here, 1, 2, 3. 3 up, 0 right. This one. 2 up, 1 right. This one. 1 up, 2 right. This one. 0 up, 3 right. Adding these two both equals to 3, right? All of them add up equals to 3. So that corresponds to nth Pascal triangle. Okay? So basically this one, if we replace this, it will become 2 to the power n. Okay? Yeah? This is kind of like one obvious way, not obvious, one easy way to visualize this. Does it make sense?
Alright.
Yeah. So actually, I think this is very important. 1 plus x. Actually, let's say a plus b. N is equals to sum of I equals 0 to n. See, there are n ways, right? I want to pick I ways to go up. A n minus I, b I. Okay. There are 7 steps I want to pick 3 steps going up and then 4 steps going right. And then if we expand this, okay. So for each I want to pick n minus I step going up and then the remaining I step will be going right.
好吧，
Last question.
走吧，走吧。
Six apples, I want to pick 2 apples. How many ways? 6 apples, I want to pick 4 apples. How many ways? 6 apples, I want to pick 4 apples. How many ways? Come on. So this is equals to 6 apples, I want to pick 2 apples, right?
Yeah.
So this is equals to 6 times 5 divided by 2.
4 divided by 2 equals 2.
What's this? 15 number, right? And then remember, actually the most important thing about this thing, right? I want you to remember this. I want you to remember this. Any number here equals to the sum of this plus this, right? Yes? So this is the same as Pascal triangle, right? Pascal triangle. You know, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? Each number is the sum of this plus this, right? And we can use the equation, right? Fij equals to Fi minus 1j plus Fi minus 1j minus 1, right? This is dynamic equation because we can iterate from the top to the right and then by filling this metric, okay, dynamic equation is the same thing. So why this is so important? Because, you know, if we replace F with C, right? C n n equals to C
N.
n minus 1 n plus C n minus 1 n minus 1. Do you see the point? Do you understand this? Combination n apple picking n apple equals to n minus 1 apple picking n apple or n minus 1 picking n minus 1 apple. Why? Pascal triangle, right? However, we can illustrate using this concept. Okay, look, I have here, I don't know, orange or apples, right? I have n orange. I want to pick n. Yeah? For the last one, right? Let's look at the last one. Last orange. How many ways? We can either pick it or not pick it, right?
Yeah.
If we pick the last orange, so how many more orange we need to pick? I say I want to pick m orange, but
Subtract 1.
yes, look. So if I pick this one, so I will have to pick n minus 1 from n minus 1 orange here, right? Because I already pick it. But if I don't pick it, how many ways? How many orange I need to pick?
M.
N from n minus 1, right?
Yeah.
So this is n minus 1m, okay?
Yeah.
Good. And then remember the condition, the boundary, right? Cn 0. I want to pick nothing from n apples. How many ways? Nothing. I want to pick nothing. What do you mean by pick nothing? How many ways?
1.
1. Yes. This is this boundary, right? Cn n. N apples. I want to pick n apples. How many ways?
1.
1. Yes. So this is this boundary, right? Yes. Okay. That's it for today. Bye bye.
Bye.
Bye bye.
Yeah.